Hello friends, so today we will create a CN model from scratch for the waste classification. So let's get started. First of all, we will download the Roboflow, which is required to download dataset from the Roboflow. And this is the you can say this is the link or code from through which we will download the dataset from the Roboflow for the waste classification. So let me run this cell. Okay, as you can see, it will take time. See data waste segmentation 5. You can see the dataset name. What but I want to change this name according to our dataset name. So the old name will be this one. New name will be waste classification dataset, and this is the code. If the we can say os.path.exit means old name is exit and new name is not exit, then we will rename it with the os.rename old name and new name. So this way it's successfully renamed the you can see the folder name of the data set. Let me refresh it. As you can see, it's changed. Now these are the libraries which is required to make a CN model from scratch, or some pandas, and you can see pandas is just for the plotation of the bar graph. I will explain later how we can use the pandas here. Okay, and one more thing, that here it is important that your model label and your images should be on the same device, otherwise during training it will be throw error. Okay, so how we can do that? It's very simple. First of all, we will use this is if statement. If torch.coda is available means which whether we have a CUDA or not. If the CUDA is available, then the device variable have CUDA value. Otherwise, it will have a CPU, and the function inside the function which we use is store the device here. So now let me show you that device which we have is CPU or a CUDA. Okay, wait for the seconds. It will take time for running. See, the device which we have is CUDA. Now this you can see train directory. Let me show you the number of classes which we have in train directory. Yes, you have seen that we have a 4 classes: hazardous, non-recyclable, organic, and recyclable waste. Okay, so let's get started. Let me run this cell, this train directory. Okay, now we have to create the class. What is use of this creating the class is that while training, we have to send the images in a tensor format, or you can say the format which a PyTorch is required, because everything is done here with the PyTorch language only in a PyTorch format. So for that purpose, we have to return the image in tensor format or in the format but that PyTorch will understand during training. So for that purpose, we will make a class. So the class name will be image folder dataset. You can see the dataset. You can say we have a dataset inheriting the dataset here. First of all, we have to initialize everything. So for that purpose, we use def init function. Root directory, basically root directory is you can see the train directory. Transformation is you can say the converting the image size from 60 by 60, or converting the image pixels value to tensor format. Okay, so these are some data augmentation or transformation. Data augmentation is like that if you want to increase the number of images, like by brightness, scale, rotation. If there is need, we will do that. Otherwise, we will not do that. We just want to convert we will apply some transformation, like converting the image size uh, from from any size from 260 by 60, and converting the pixels value to tensor. And also we have to change the dimension from hwc to chw, which is required. So let's get started. So this is a root directory which we initializing here. Okay, then a transformation, if there is any transformation which we have to apply on an image. Okay, now what is the use of this? When you will os.list directory root directory. Okay, when you will do that, it will be the old folder name. Folder name, you can say here folder name basically act as a class name. So folder name is I can say the list of all the class name present in that particular directory. After that, when you use the sorted function, it give me sorted function, it give me the list of all the class name on a folder name inside a train directory. Okay, list of that in a sorted format. Now we have to connect this hazardous, or you can say this class name or folder name, with the class id. So how we can do that? This is very simple. Just use this form. You can see the for loop here. You can see this here. We are making the list, or you can see dictionary here. For ideas, class enumerate self classes. Let's see classes you can for a list of all the folder name present in the particular directory. After that, when you will do that, just class means here you can say A class is basically, you can see the class name, and you can see the ID is connected with the IDX. So you can say, for example, hazardous, recycle, non-recycle. You can list of self dot classes, and when you will use this line here, you can say that you will use this code, you will get this type of result. That zero is basically connected to hazardous, one is connected for the recycle, and two is mapped with the non-recyclable. So this way we will make a class to ID dictionary. Now, self dot sample. Basically, what is the use of the self dot sample? Make a pair of two things, that complete image means image path is mapped with the class ID, individual class ID. So how we can do that? Just very simple. For self dot classes, give me the class folder name, or you can say we loop over it. We have to make a complete folder paths. So how we can do that? Just to use os.path.join, then root directory, then the class. We will get a complete folder name, folder path, and if the folder directory is exit, if it is not exit, it will go do continue. Otherwise, we will move to this for loop. Inside this for loop, we will make a list of here. First we will make a list of all the images present in that particular class name folder. We will loop over the image path, or you can see the image one by one. Okay, after that we will iterating over the image path one by one inside the particular class name folder. Okay, we will make a complete image path. How we can make it? Just see, very simple it is. os.path.join class folder and the image name. We will get a complete image path. After that, we will map the image path with the class ID. So how we can map it and append it to the sample? It's very simple. It is just use this. It's very easy. First of all, we will make a pair of image path and self.class to class ID IDX, the dictionary which we have created here. It's very useful. Here we are using it. Class ID then class name. Just give the class name. You can see the or you can see the folder name. The image path will be mapped with that particular class ID. So this will be make appended it, and after that, when you will use this land function, we will use self.sample. It give me the complete number of images which we using for complete training. Okay, now get item, basically we have to pass one parameter idx. Where the use of id is that it can fetch the image path. Means here you can say uh, we are pairing the image path and the class id. So when you will use this IDs, it will fetch two things: image path and the label related to that particular image. After that, we will open that image and we will apply some transformation. If there is any transformation, we will apply the transformation to the image, and we will return the image with the label of it. Now let me run itself. It's very important. Now this thing, we have to plot the bar graph. What is used to this plot of bar graph? It tells that how number of images present for that particular class. So let's get started. Same thing, we have make a list of all the folder name present in a particular directory. We loop over them one by one. After that, we will make a path of that complete folder path. So it's very simple. It is where the path.join train directory in the folder. You will get a complete folder path. We will make a list of all the images present in a particular not lim, make a list. We will see that is the directory is exit or not. If it is exit, we will move inside the if statement, and then we have to make a list of all the images present in that particular class name folder. Then we will use a length function and give me the image count, at how many number of images present for that particular class name folder. After that, we will make a dictionary here which store folder name, or you can say class name, where its number of images present for that particular class ID. Then we print the count dictionary. You will see the result of like this: Hazardous 473 images present, non-recyclable 405, recyclable 460, and organic 469 number of images present. So after that, we have to extract everything. So how we are extracting it? Just for the for the production of the bar graph, it's very simple. Like how to get a classes. No, you can say class name. Just use this count dot keys. Give me the class's name and counts for each class name. So it's very simple. You have to use count dot values. Give me the list of all the give the count of all count for each class name. After that, it's very simple. For the protection of bar graph, we have to use plot of figure. Figure size will be 12 by 6. For the protection of bar graph, we use plot dot bar and the classes, because for the axis and count for the y axis. You can say x label, y label, title, except rotation. Means rotation basically this thing. Okay, rotation this thing, and tight layout. Then show. Let me run it now. See, before the rotation is 45. Now let me explain you. If suppose I will keep it here 45, see the difference. Okay, see tiltness of this class name. If it is 90, it will be straight. See, so this is the use of this rotation here. Now we have to create a data loader which is useful for sending the images, number of images in the batch during the training. So how do we define it? For that purpose, we have to use from torch.utils.data import data loader. Okay, now there is a transformation which we have to apply. First of all, for applying the transformation, we have to use transport.compose. Then we have to create a list of all the transformation which we have to apply. So here it is a list. First of all, what we want to apply, we have to resize the pixels value from pixel from to means resize the images to 60 by 60 pixel value. After that, we have to convert it pixels value to tensor. Basically, to tensor is scale the pixel value to 0 to 1. And one more thing, that to when we are applying the to tensor, the dimension of the images from HWC convert to CHW. Okay, that's why to tensor is required. And then we have to add the normalization also. So how we are applying it, just we have to apply normalization and give value to mean and standard. Why there is a three values here is because for the RGB channel, because each image have three channel R and RGB, so that's why we have a three values here, mean and standard. It give me the normalized pixel value. Then we have to create it after applying the transformation, the function will be closed and just is stored in this variable. Okay, so after that we will have to make an object of the class which we have created. So train dataset, basically the object of the class which we have created. Here we just we have to pass a to directory, and the transformation which we have you can say defined here. To apply this transformation, we have to just pass the transformation variable. Okay, so here it's apply the transformation to the image. Now we have to create a data loader. So this is a data loader function. Here we have to pass a object. Batch size 32 means when all the number of images divided into number of batches, then each batch has 32 images. Shuffle true, yes, we want to shuffle. Number of workers will be 2, and pin memory will be true. So this is a use of this train loader, or you can data loader. So train loader is this thing now. So let me write it now. We have created data loader also. Now when you will see train dataset dot get item 0 0, why we're passing it, because you already know in classes the class which we have created, we have to give the parameter. We have given the one parameter idx which retrieve the information using the idx only, image path and the label. So for that purpose, here get item, we have to pass 0 index value and 0, then dot shape, give me the shape of the image. Okay, let me run it now. Okay, 360 60 by 60, you already know this is a CHW format. And why it's converted to CHW format? Because it's because when we have to when we use to tensor, it's basically convert the image dimension from CHWC to CHW. Then when we retrieve the information length of train loader, it's 58. Why it's 58? 58 means 58 batches is present, and one each batch 32 images is present. This is the meaning of this length here. Okay, now we have to plot the images. So how we have to just plot the images? You can say the class names are hazardous, non-recyclable, organic, and recyclable are the classes which we have. Now, for getting this, for the production, it's very simple. First, we have to create the iterative. Then we have to use the next function. Then we will get this sample and labels. Basically, sample and labels store the information of 32 images. Okay. Now, for the protection of 16 images, we have to use this line, plot.subplots, 4 rows, 4 column, figure size will be 20 by 16, and figure basically represent the entire subplot. X is just for the iteration over the subplots. It is in a 2D format, and when we use X variable, it's converted to 1D format just for the ease of iteration. Now for the protection of 16 images, we have to loop for loop to 16 times. So here we are looping it for the 16 time. Now class name will be for getting the class name for the particular image, we have to use label.I dot item, give me the ID. Then when we use this class name, you can say list of this, we will get a class name for particular image. And then we have to use this sample I. So what is the use of this permute here? Sample I, one image, you already know that whenever you use this dimension, the dimension will be CHW. You have seen this. So to for the plottation, we have to regain the original dimension. So how we can do that? Just use the permute 1 to 0. It's converted CHW dimension to HWC just for the ease of you can say the plottation. Access.I, I'm sure will plot the image, and set title will be set the title. Now let me run it. Let me see that the labels is currently assigning the current image. Okay, recyclable, you can see the image are highly contrast or not, it's and so much blurry because the size is reduced to 60 by 60. And also we have some use this mean and standard, we have normalized the pixels values. Okay, non-recyclable, hazardous, organic. Okay, so I think so. uh, perfectly perfectly labels and images are perfectly mapped. Now we have to create the CNN model from scratch. It's very simple. Now let me explain you. So these are two functions which is required to create the CNN model from not function. You can say the library. Okay, the other two library which is required to create a CNN model from scratch. First of all, we have to create the class. Class name will be CNN. Then anandroid module. We have to pass it. You can see the inheritance is performing here. Now we have to initialize here. See, first of all, let me explain you one thing, that here we just defining all the number of layers which we have to used in CN model is defined here. We are not connecting them here. We are just defining the number of layers which we have to used in this function def dot init. Okay, so how we are doing it, just very simple. It is def dot init self number of classes which we have is not 20, it is about 2 4. We have only 4 number of classes. Okay, then super cn dot self, this is, you can say, inheritance is performed here. We are calling the super class. Now one more thing, that input image dimension will be 3, matlab, 3 will be the channel RGB, then 60 by 60. And one more thing, that the output, to get that output dimension of the layer will be calculated by this formula. Here basically the n will be the input dimension. Okay, then the k will be the, can say, the kernel size, p will be the padding, and s is will stride, and plus 1. What is the use of this padding here? Let me explain you. So padding, basically, if the padding value will be 1, it apply the 0 0 layer around the image. And what is the use of stride here? You can see this stride is basically the use for the calculation. Okay, and what type of calculation is like this thing? Okay, suppose this is, you can say, the this complete is an image, input image, and this is a kernel. You can say kernel, or you can say the filter. When we apply this kernel over this image, this type of calculation will be performed. This type of calculation will be performed. So this basically, when we moved, you can say, move to rows or rows, this basically stride, if the stride value will be 1, calculation perform like this: red, green, and blue. If the stride value will be 2, then it will skip this row. Row will be skipped and directly move to this place here. So this is the use of the stride here. Okay, now let me explain you how we have to explain how to define the first layer. It's very simple. It is just anon dot convolution 2D. Then we have to make it say pass the in channel. The in channel will be 3. Why? Because input image will have a 3 channel RGB. Output channel will be 16, and kernel size which we are using is 3 by 3. Okay, so this way we have defined the first layer, and after that we have to define, and the output of this dimension output will be like this: 16, 58 by 50. You have done some calculation. You can easily use this calculation: 60 plus minus 3 and 0 here, because the padding value will be 0. Why? Let me explain you. In convolutional 2D, padding value will be 0 by default, and a stride value will be 1 by default if we did not define it or change the values. Okay, so because of that, when you will do some calculation, you will get this dimension only. Now after that, we have to apply the max pooling layer. So how we do can apply the max pooling layer? It's very simple. It's We have to use anon dot max pooling then 2. This is basically 2 will be the kernel size. Okay, if we are using the max pooling for the kernel size, you see that for in the stride value will be, the stride of the window default value will be as same as of the kernel size. For that purpose, when you will do some calculation, you will get to know that when we use this stride value will be true. So here we will divide by the 2, and the dimension which we get is 16, 29 by 29. Okay, and why here it is come to 16? Because input output channel will be 16, so here 16 will be the channel here. Okay, of the conventional layer. Of Okay, on max pooling layer, you can say it. Now we have to define what the second convolution layer. It's very simple. First of all, what will be the input channel? Input channel for the second convolution layer will be same as the output channel for the first layer. So output channel for the first layer will be the 16. So it's act as the input channel for the second layer. 32 will be the output channel. Then 3 will be the kernel size. Same calculation will be done. You will get this dimension. 32 is 27 by 27, and we have make a second layer. Now same way we have to make a max pooling layer. So it's a max pooling layer like this. So I have not explained you the result what is the use of max pooling layer. So let me explain you. Suppose the max pooling layer is like this. it do some calculation here. When you will do the kernel size over this area, okay, you will see maximum value. What is the maximum value here is, you can say in red region will be 20, in yellow region the maximum value will be 30, in blue region maximum value will be 112, and green the maximum value will be 25. So this is not 25, 27. So this way the calculation is performed for the max filling. It will basically reduce the dimension. Okay, come back to here. Now for the third layer, same thing, the output channel will be 32. You already know how it's coming to 32 because the output channel for the second layer is 32, so that by 32 will become the input channel. Now 64 become output, 3 will be the kernel size. Same way the max pooling will be used. Now after that we will flatten the layer. Everything will be flattened. Basically all the 3D formats convert to 1D format. So that purpose we use AND flatten. So let me show you the image for that. It's like this, that if the layer is this one, if we apply the flattening, then all the neurons will be converted to 1D format. Okay, all the neurons. So what number, how to calculate the number of neurons is very simple. You can say the output dimension for the last layer before the flatten is this one, 64 5 by 4. The number of neurons will become to 64 into 5 into 5 into 5. It becomes 1600 number of neurons, like this. After that we have to apply the fully connected layer. So first of all, the AND dot linear will act fully connected layer, and the input dimension will be 64 into 5 into 5 into 5, and 256 will be the output. And the second is AND dot linear, 256 will be the output, sorry, input, and 128 will be the output. And the last layer will be according to number of classes which we have. We have a 4 number of classes. So last fully connected layer will be defined by FC3, and input will be 128. As you can see, this is the input. Number of classes according to number of classes will be defined. And what is the use in the full? Why we will call it a fully connected layer? So it's very simple. You can see this here, this image. As you can see, this is a 3 fully connected layer. The fully connected layer, why it's called it, because each neuron in fully connected layer is connected to the previous all neurons. Like this neuron is connected to all the neurons before it is, and same way this here, it's connected to all the neurons before it is. So this is a use of this. That's why it's called a fully connected layer. Okay. Now we have to connect them. So it's very simple. For the connection of them, we have to use X, where X is act as an image which we pass it. Okay, self dot convolutional one, it will connect the image. Then we have to apply the ReLU activation function. So what is use of ReLU activation function? It's basically very simple. All the values, pixel values which is less than 0 will convert to 0, and all the values greater than 0 will remain as it is. As you can see, 250 remain as it is, 27 remain as it is, 61 as it is, and 101 as it is. So this is the use of the ReLU activation function. Okay. Now for the connection of the second layer, it will be self convolution 2, and third layer self convolution 3, ReLU, pool 2, pool 1. And see what is the use of the self convolution 2 or pool 2. These are the variable names which we have defined for the for defining the convolutional layers. Okay, so convolutional 1, pool 1, pool 2, convolution 3, this way. So this way the connection is going on. Okay. And after that, this flatten, we have connected it flatten. The common thing is that we are using the X in every layer, and for X for the connection. Okay, then a fully connected layer, then a ReLU, then second fully connected layer, then a ReLU, then the last layer will be this one. Okay, this is not 20, this will be the 4 here. Number of neurons which we have is 4. Classes which we have is 4. That's why. Now we will create the, you can see here we have created the model, you can see the object model. Then we have to define pass it to the device which we have, whether we have a CUDA or a CPU. So this way we have created the CNN model from scratch. Now we have to know the summary for it. For the getting the summary, we have to use torch vision import summary. We have to pass the input model and the input dimension of the image. We will get the summary here. You can see it. 1658 for the first convolution, max pooling, it will give the dimension, and number of layers which we have is this thing. We have a 10 layers, and these are the parameters. So total parameters which we have is 46852, and trainable parameters is 46852. So this is a use of it, and you can see these are the memory size. Okay. Now we have to define the entropy, the loss function, and the optimizer which is used for the updation of the weight. So you can see we are using this thing, cross entropy loss, because number of classes which we have is greater than 1. So that's why we are using the cross entropy loss. Okay, for the multiple classes. And optimizer which we are using is Adam. model parameters which is trainable, and learning initial learning rate will be 0.0006. Okay, so this is the optimizer which defining it. Right now I'm just training it for the 10 epoch. I already have the model which is trained on 50 epoch. Okay, so I will train just for the 10 epoch. Okay, and we'll see the result of that. Now we have to define the model for training. We are using the PyTorch format for training it is. So let's get started. It's very simple. We are using TQDM for the visualization, pattern visualization, or you can see the progress bar to see the progress bar clearly. Okay, so that's let's get started. Initially, the training loss and training accuracy list will be empty because we have to store the each epoch training loss and training accuracy. Then we have to move to the for loop for the epoch. The number of epoch initially will be 10, so 10 iteration will be there for loop for the epoch. Then model.train, here it's very if we do not use it, if model means model mode will be training modes, because of that only the updation of the weights has to be performed. Otherwise the weights will not be performed if the model is in a evaluation mode. Okay, the correct initially the correct value will be 0 for the epoch, or you can say the first epoch. Then running loss will be zero initially. Then the total sample, basically total number of sample proceed during training. Okay, for each epoch you can say. Then we have to define a TQDM function. Here we passing the train loader. Okay, then the message which we want to display, leave true. What is use this leave true? Keep progress bar after completion. That's why we use leave true. Then we will loop up the progress bar. Let me talk about the first iteration. If we're talking about the first iteration, labels and data will store the information for the 32 images. Then we have to move labels and data to the device which on the model will be. So here we passing it. Then we have to use optimizer zero grade. What is the use of this optimizer zero grade is that we have to make all the gradient value or reset the gradient value to zero, because if we do not do it, then the gradient value for the previous batch, because this is a, we can say we are passing the batches here in this for loop. So previous batch gradient value will accumulate it in the current gradient value if we do not use this optimizer zero grade, and it disturb the training of the weight, or the training will not perform properly. So that's why we have to use optimizer zero grade here. Then we just directly pass the data to the model. It give me the output. Okay, output like this. And compute loss between after getting the output, we have to compute the loss, or you can see the we have to calculate the loss. For that purpose we already use the criterion cross entropy loss. So here we just pass the output and the label, it will calculate the loss. Then loss dot backward basically calculate the gradients value. Okay, here the calculation of the gradient value is performed according to the loss, but the updation is not performed. Updation is performed using a optimizer dot step. Here the updation of the gradient value is performed according to the loss, or according to the calculation of the gradient values. Okay, now this thing is very important that accumulated total loss will be multiplied by batch size for current averaging later. So here we accumulate the running loss for each batch. Okay, for each batch we accumulate the running loss. Okay, so here it is going on. Loss dot item give me the running loss for the particular batch. After that we have to get a prediction. How we get a prediction using this optimizer. You can say prediction list of for the all the 32 images. I want the prediction made by the model. So how we can do that? How we can fetch them and get in the dimension and get in the list. So it's very simple. We use output dot argument max dimension burn. Okay, which give me the, you can say the list of all the list of the prediction made by the model. Okay, for better explanation, let me come back with some comment with example. Okay, so let me explain you how it's working. Suppose we have a batch, only two batches there, and the we have a three classes. So this way you will get the output like for the two batches, and for the batch of two samples. Okay, for the batch of two samples and three classes, mean to in each batch two images is present, and two images present for the in each batch, and three classes is present. So this way you will get the prediction, or you can say the model output. And as you can see, this is a list 0.1 0.7 0.2. So this way when I will use this argument max dimension one, it give me this value, means maximum value in for the sample one, or you can say for the image one, it give me the prediction will be 0.7, and for the image two prediction will be 0.8. And when we will use this, you can see the it will give me the prediction list, and it will use this output or argument dimension mode. It'll give me the list of all the prediction made of for the particular number of images. So here we have a two sample, but here this prediction basically length will be 32. So that's why we'll give the prediction. After that, we have to make how much prediction is, how many number of prediction made by the model is correct or wrong. So and we have to store it. So how we can do that? So for that purpose, we pass the prediction is equal to length, means all the prediction which is equal to the label will be counted, and all will be rejected, and all this and that particular sum will be stored in this correct. Okay, then we will make all label dot size 0 will give me the total sample for the each batch. It will store in this total sample accumulated. Then everything is done. Now here, after this line, everything is done. After the means after this line, batch folio will be completed. Okay, so now the epoch, after epoch, you can see the epoch for loop is activated, and here we have to display the epoch loss and epoch accuracy. So epoch loss we will calculate like this: running loss divided by the total sample, and calculation of epoch accuracy like this: 100 into correct means here which we have calculated, number of prediction about the model is correct, then divided by the total sample. Then we have to append it to the total train loss and train accuracy for the protection of the graph. Then we have to display just masses here. Okay, so let's get started the training for the tiny epoch. Let's get started. Now we have to for the protection of the graph, we will have to first make the range. So here we have to make the range according to the epochs which we have. For the protection of the graph, we will use plot.subplots here and figure an ax1. ax1 dot plot use the x well for the x you have to pass the epoch log, and for the y we have to use the train loss. R dash means the line will be red and it will be straight. Label will be train loss. X label, Y label, title, legend, and plot dot show it will directly show the graph, and same before the training accuracy. Now training is going on, I think so. Yes, epoch 6 will complete it. Now we have to save the model. So how we can save the model is very simple. We have to, for the saving the model, first we have to create the path where waste.pth. For saving the model, we have to use this line: torch.save model.state.path. It's save the model. No, this line is not important. It will save the model. Now let me, I think so training gets completed for the tiny epoch. It's almost completed, so wait for it. Let me see the result of that. So training gets completed. Now let me show the graph for the tiny epoch. As you can see, loss is going down continuously and the accuracy is increasing continuously. So it's good. Now we have to save the model. As you can save the model, you can see this waste.pth is saved here. Now we have to load the model. It's very simple. For loading the model, we use model.load the state dict, torch.load the path of the model, then map location will be device, model.toDevice will be device, then model evaluation. Now here the model is in evaluation mode, means no gradient updation will be performed during testing or during evaluation. Now this thing is important. Now we have to plot the images, or you can say test the image, test the model. So how we can do that? First of all, we have to make the test directory. This is a test directory. OL list directory, give me the old folder name inside the particular test directory. Okay, list of all the folder name present in the particular directory. Now pre-processing of the image, which is required during testing, and it's important, but I have to say that it's important because what all transformation which we had applied to the images during the training has to be there during the testing also. Means like important transformation like size to tensor. Okay, so it's very important, and let me explain you. It's directly we are recalling the transformation variable which we have defined above, which directly convert the, you can say, image to 360 by 6 means the dimension to 60 by 60 dimension, and directly apply the two tensor, and also directly apply the normalization to the image. Then here unsqueeze 0, why we apply the unsqueeze 0? As you can see, during training we are passing the image into the batch dimension. Okay, here is we are passing the image into batch dimension, means the data dimension is like this, and means the batch dimension, then it's come to C, then it's come to H, then it's come to W. This will be the dimension of the data. So same dimension has to be applied to during testing. For that purpose, we use image.unsqueeze, which add one dimension to the image, like 1 3 60 by 60. Okay, means one image is present with size 360 by 60. So this way, this is a pre-processing of the image. It directly gives return the image after pre-processing. Now same thing, we have to plot the just we have to plot the four images. So just one row, four column. Same thing, train dataset dot classes give me the class name of all the which we have done. We have used during training. Then for the prediction of four images, we have to loop the for loop for the four time only. Then first it will randomly select the folder name from the text field variable. Okay, like this one, which give me the folder name for all the folder name inside the test directory. Randomly select one folder name. After getting the folder name randomly, we have to make the folder path complete folder path. For that purpose, we use os.path.join test directory and the folder. Then after that, we will make the list of all the images present in that particular class name folder. After making it, we have to make random means we have to make a image path, complete image path. So how we can do that is very simple. It is os.path.join, then a test directory, then the folder name, then randomly it will select the image path from the list of the image. After that, we will open that image. Then we have to apply the pre-processing on the inside over the images. Okay, then we pass the pre-processing image to the model. It will predict something. To get the prediction, it's very simple. Torch.argument output.item give me the prediction made by the model. You already know what is use of this argument max. I have explained above during training. Okay, after getting the prediction, we want to know the class name. So how we can get the class name? Just use this class name, just pass the prediction in, and we'll get the label. After getting the label, just we will show the image and the title. Then we have to plot the show. Now let me see the result of the model, which is trained on tiny box. Organic, no. Recyclable, it should be organic. Newspaper box, non-recyclable, wrong. Show again. Hazardous, organic. It's not working very well, but if you will train it for the 50 epochs, it's work very well. Now let me upload the model which is trained on you can say 50 epoch. Let me show result of that. Okay, so this is a model which is trained on 50 epoch. Now we have to upload the model. For uploading the model, we have to change the model. You can say the model name, or you can say the path of the model. Now let me run it. It's load them now. After loading the model, now we have to plot the 16 images. Before that, I'm plotting the 4 images, but now I want to plot the 16 images. So some changes is there. 4 rows, 4 columns, and for loop will be 16 times. It's very simple. Now let me run it. Let me show the result of the model which is trained on 50 epochs. Okay. Non-recyclable, recyclable, non-recyclable, hazardous, non-recyclable, recyclable, hazardous, recyclable, hazardous, organic, non-recyclable, recyclable, hazardous, recyclable. Okay, it's working very well. And if you want to increase more accuracy or loss or decrease the loss, either you can increase the conversion layer or decrease the conversion layer, or change the hyperparameter values, or you can say increase the kernel size. It's up to you what you want to do to increase the accuracy and decrease the loss. Okay, so hope you understand better that how you can create a cn model from scratch. If you gain some knowledge from it, so please like, share and subscribe my channel. Thanks to all.